Hey class, Absolute 5 here. So today we're going to be talking about vertical asymptotes. Now, what is an asymptote? Think of it as a border or a wall or something that prevents a function from actually passing through. Think of it as, think of, where the crossing guard or where construction workers, they put like these signs that you can't really go in this section at all. Think of it that way, that you can't cross this specific section, but you can get pretty close to it, but not actually go through it. So let's define what is a vertical asymptote. So this is the definition. So it's the line x equal a is called a vertical, it's called a vertical asymptote, spelled like this, of the curve y equals f of x if at least one of the following statements is true. So this is the limit as x approaches a of f of x if it gets if it goes to infinity. And then we take the limit as x approaches a from the left of our function, whatever that is, it's still infinite. And if we take the limit as x approaches a from the right of f of x of our function, it's still infinite. And also, it's true that if the limit, it doesn't have to satisfy all of these conditions, but if it satisfies most of it, then it's fine. So if I take the limit as x equals as x, it's the limit that x approaches a for our function is equal to negative infinity. It also has to satisfy the limit as x approaches a from the left of f of x has to go to negative infinity, and the limit as x approaches a from the right of our function, it goes to negative infinity. So it makes sense that at least one of these statements is true. So meaning that, again, your function is getting really close to like this invisible wall, but it's not going to like hit this thing. It's just going to go like whoop. It's going to go curved up. It's not going to, or it could even just curve down as well to avoid this barrier. So let's have a physical example. So that's what I would like for you guys to think of as a vertical asymptote. Vertical asymptote is like borders. Okay, so what's our example? Let's see. What's our example? If we take the limit as x approaches 3 from the right of 2x over x minus 3, and we have to find the limit as x approaches 3 from the left of 2x over x minus 3. So by default, if we plug in 3, we already know we're going to get an undefined situation. That's why we're taking the limits from the right and from the left of our function. So we're really going to actually take estimates. So let's just take one estimate on each side real quick. So let's say x is 4, because technically from the right of 3, you're in the positive zone of the real line. So let's say I take x is 4, that means if I take the limit of this, so that means this would be 2 times 4 minus 3, this becomes 8 over 1, which is the value. And now let's take negative 4. We get 2 times negative 4 over negative 4 minus 3, I get negative 8 over negative 7, which is still 8 over 7. Positive. The point is that we're still getting values that are going to eventually, if we keep picking bigger numbers, they're going to get bigger, but if you notice, the right side is going to get infinitely, what's the word I'm looking for? Oh, actually, is there a better one to use for this? The 3, let's pick a different number. Let's pick a different number for 4, actually. Let's take a different number, actually. Because it seems kind of interesting if you pick negative. Oh, okay, I see. It makes sense it's gonna make sense when I draw this. Oh, let's pick a different value. Let's say 2. Because 2, right, it makes sense. I should have picked 2. I went too far to the left. Let's pick 2, because 2 is right under 3. So then if I say 2 times 2 over 2 minus 3, now this makes sense. 4 over negative 1, which is negative 4. So why do I want this? If we notice that the value if we keep going further to the right, my function is going to keep shooting out to positive infinity. And if I keep picking values that are less than 3 or close to 3, it's going to keep shooting down to negative infinity. So for argument's sake, I'm going to draw it so you can understand what I'm talking about. This is 0, this is x, this is y. Okay, so 1, 2, 3. This is 3. 1, 2, 3. Okay, so this is what I want you guys to understand, that if I pick values that it was 4, this function is going to keep going off to infinity like so here. But then when it's getting close to 3, it just shoots up like this. As for from the left side of our function, it's going to shoot down like this. So that means there's an invisible barrier here, which is when you say x equals 0, it's preventing the function from actually going through this section. That's why it's called a vertical asymptote. It's a barrier. It protects, it prevents the value from crashing, because if you put x equals 3, we get undefined and we get a whole lot of problems. That's why think of these vertical asymptote as a barrier. So that's what I was trying to say, that when I pick negative 4, I'm all the way over here, when in reality I should have picked values like 2, 2.5, 2.9. You see how far it shoots down? If I keep picking values, it's going to keep shooting down this way. So if I pick, let's say 3.1, it's going to keep shooting up to positive infinity. So the point that I'm trying to make is that if I were to actually take the limit as x approaches 3 from the right of our function, it'll shoot up to infinity. Well, let me actually write it on the other side. That would make more sense, alright. If I take the limit as x approaches 3 from the right of our function, 2x over x minus 3, it goes to infinity. And then I take the limit as x approaches 3 from the left of 2x over x minus 3, it's going to shoot to negative infinity. So therefore, it satisfies the condition that we just stated, that it's going either positive or negative infinity from the left or the right. As long as it met one of those conditions, it's true. So it actually met 2 conditions, which is even better. So guys, that was the lesson for you guys today. I want to thank you guys for watching. Absolute 5. I'm Roger Palomino. Be sure to like, share, and subscribe to my channel. Also, if you like my content, if you have any suggestions, leave a comment below, and also hit that bell button next to the subscribe button, so this way you can get further notifications for more math. So So that's everything, guys. So never forget that math is infinite because there are infinitely many possibilities. So you guys have an absolutely lovely day.